All right, hello, Algebra 3. This video is to help you understand the 12 basic functions. All right. All right, so we're going to review function properties and the 12 basic functions. All right, so before functions, you need to understand that comparing any two things is called a relation. So here's an example. Comparing vehicle type with the number of wheels that they have. And when you have a relation, the members, the two pairs, could be sets of anything. So obviously a boat has no wheels, bicycle has two, motorcycle has two, cars and vans have four, and big trucks can have anywhere between 4 and 22 wheels as long as it's an even number. So this type of data display is called a map. We can also display the same information as a table. You're more familiar with those. You can also express them as ordered pairs, which is the same data from a table, just put into ordered pairs, x and y. Now let's talk about the F word, the functions. Functions are well-behaved relations. One variable of the function depends on another for its own value. And here's the key sentence. To be a function, each input, which is the x value, must give only one output, the y value. All right, so again, when any teacher asks you what's a function, the simplest response is a relation where each x value produces only one y value. All right, so imagine this in math. All right, imagine you have the function y equals x squared, and your input for x is 3. Well, 3 squared is 9, so the output is 9. Can you think of any other number that you could input for x that would give the same output y? Negative 3. If I square negative 3, I also get the same output as 9. So see, you can have multiple inputs give you the same output, but each input will never give more than one output. All right, you'll be asked to determine if it's a function on a graph. You do this with the vertical line test, and the way to check it is each x value should only be used once. All right, so here is a graph, looks like a horizontal parabola. If you take this vertical line and sweep it across, you can see that it touches 2 points at the same time. All right, and like right here and right here. And that shouldn't happen with a function. So immediately it fails the test. This is not a function. Here's a wavy function. If you take the vertical line across it, you can see it passes because it only touches one single point on the function at a time. And that means it passes and it is a function. This wavy one also is going to fail the test though, because it touches in some places 2 spots, but in some it even has 3. Oops. So like here, 1, 2, 3 values. So it's saying that this x value of -1 has 3 different outputs. That does not make sense in function land, so it's not a function. Here's the same ones with mapping. You can see that each element of the domain, the x, has only one output because it only has one arrow. That tells me that this is a function relationship. This one also is a functional relationship because each input is giving this just one output. Even though they all have the same output, that's okay. Y's can repeat all day, but x's never can. And here, this one's not a function because look at 2. It has 2 different outputs. If I input 2, it should only give me 1, but it gives me 3 and it gives me 5. That's chaos. You can't have that. That is not a function. You're going to be asked to identify continuous functions, and the simplest way to understand it is just you don't have to pick up your pencil to draw continuous functions. You can see these 3 examples here. If I were to ask you to sketch these, you could do it without picking up your pencil, which tells you it's continuous. There's no break. These are discontinuous functions. They either have what we call holes or asymptotes, which are lines that the graph can never touch. And if I asked you to sketch these on a piece of paper, you would definitely have to pick up your pencil to draw these 2. So that's how you can tell if it's discontinuous or not. Piecewise functions are functions that are made up of several different families of functions. Like this one here is made up of 3 different linear families. All right, this is a line, that's also a line, but it's not one continuous line, so it's not a single function, it's many. This one is made up of several. We've got a parabola here, which means it's quadratic. A horizontal line is called a constant function, and then any other type of line is just part of the linear family. So since they're not all the same function, we call it pieces of different functions or piecewise. Domain range. All right, this is basic. Everyone's got to know it. Let's review it. Domain is the set of all x values of a function, and range is the set of all y values of a function. Elements of the domain and range are listed in order from least to greatest while omitting any duplicates. All right, so look at this one here. All right, the image has highlighted the domain to look at from left to right on the x-axis in red, and the range in aqua up and down on the y. And this is, I love this example because it focuses in on the most important things. So domain, left and right. You can, because the graph has an open circle, the domain marker has an open circle, and it stretches all the way from -3, this graph, all the way to +1 on the x-axis. So that's where the domain stops. So that tells me the domain goes from -3 exclusive all the way to +1 inclusive. So to write that with inequality notation, interval notation, we use parentheses to open it up to let people know that it starts as -3 but doesn't include it. And then it goes all the way to +1, so we put a comma, and it goes all the way to +1. Now 1 is included, so to let people know that, we use a bracket. Then for the range, least to greatest, the lowest it goes is down to -4, and it is included. All right, so we'll write -4 with a bracket. That's the lowest value. And then it's hard to write with my finger here. You have to excuse me. And then it goes all the way up to 0. But notice that on the aqua identifier, it is solid. And even though this is an open circle, look at this value here at 0, 0. That is solid. So that means 0 is going to have an output. So we need to include it, not exclude it. So it definitely gets the brackets there. Here's another example. All right, domain, left to right. It goes all the way from -5, and it's solid circle, so that means we include it. And it goes all the way to infinity. See this arrowhead as we follow it to the right? It doesn't stop at 4. We just don't have the ability to write or to draw it forever. So we use arrowhead, so it goes on to infinity. So because it starts at -5 and it's included, we use a bracket. And it goes all the way to infinity. And since absolutely nothing can equal infinity, you never include it. You use the parentheses to exclude it. It's not a real number. Now the range goes from least to greatest. So start at the bottom because that's where the least numbers are, and up and down y. So the bottom, again, an arrowhead. That means it's going forever down. Well, going forever down means you're headed towards -infinity. And just like infinity, nothing can equal -infinity. So you always use the exclusive parentheses. Then ask yourself, how high up does it rise? Well, it rises up to a level of 5. All right, you can see on the range indicator here that it goes up to +5. And because it's a solid circle, it's inclusive. And we use a bracket to close it out. All right, now, functions that behave in similar fashions are grouped into function families. This is where the 12 basic functions come from. These are the most important functions in all of algebra, and they're the ones we study almost exclusively. And then the most basic member of each family is called the parent function. All right, so let's look here. The most basic is the linear function. And whenever it's a completely horizontal line, it gets called the constant function. And whenever it's perfectly diagonal, a y equals x line, it sometimes gets called the identity function. But they're all just forms of linear. And you can always identify linear equations because their highest power of x is always 1. So if I have y equals 7x plus 6, I know that it's linear because x is being raised to the first power. The next family is the quadratic function family. They give us a parabola, and we can identify quadratic functions based on that and also on their equation because their highest power of x is 2. Cubic functions give us this snake-looking feature, so when we see that, we know we're looking at a cubic function, and they can be identified in equation form because their highest power of x is a 3. Rational functions, think of ratio, the root word, think of ratio is a fraction. This sometimes gets called the reciprocal function. Their graphs are always have a couple of curves at least going through them. They're always going to be broken up by a vertical asymptote at some point, because if you have a variable in your denominator, like rational functions do, there's a risk of you dividing by 0. And you know that you cannot divide by 0, and if you do it, the answer is undefined. It makes no sense. So that's why at x equals 0, this line right here, you see nothing, because 1 divided by 0 makes no sense. So there's no output. You can't graph it. So you can always identify rational functions if there's a variable in the denominator. Square root functions are obviously when you have the square root of x in your equation, and their functions look like a little eyebrow right here. They start at the origin and go off to one side or the other. Absolute value functions, think v value, then it gives you a v-shaped graph, and then it's easy to identify them because they have the absolute value bars in their equation. Exponential functions, they've been talking a lot about that on the news, flattening of the curve, things like that. You can identify exponential functions because they start looking like a flat line and then they raise quickly up. You can identify them in equation form because the variable x is the exponent, therefore exponential functions. So look for x in the exponent and then you'll know it's exponential. Logarithmic, it looks like the mirror image of exponential, right? It starts by going up vertically fast and then flattens off. It's the exact opposite. And you can tell you got a log function because it'll have a log in the equation. Greatest integer functions, this is not going to come up. We don't study in Algebra 3. You can ignore those questions. The other functions have to do with trigonometry, and we don't do any of that in Algebra 3, so you can skip those. And I know that you may be tested on, so I plan on adding a curve to everyone for having to deal with that. So let's do a quick function family feud. We've got 6 different function families, and I'm going to connect them based on their name and their equation. So absolute value, remember the value starts with a V, it has a V shape, so that's the absolute value family right there. Rational, that's where it has a variable in the denominator, and remember it's going to have at least a couple curves and always at least one vertical asymptote, so that's the sucker right down here. Quadratic, you can identify them because they have 2 as their highest power, and they always have parabolas, so that's that. Cubic is always to the 3rd power, and then its graphs look like snakes. That's that one. Linear, that's the easiest. X is always to the 1st power. And then square root, it looks like an eyebrow, and of course it has square root in the equation. So that's that. Keep hitting me up with your questions. Hope this was helpful. I'll share these notes online. And good luck. Miss you guys. It's really boring being at home. Wish I was in class. And talk to you soon.